Okay, I'm back for part two. I've got my calculator handy with me, and I've realized already on my way to look for it that I made a little boo-boo here. This is a negative x squared over here to combine with the 4x squared, so this should be 3x squared, but neither of them are factorable, unfortunately. So, as a result, if I'm going to figure out the ratio of the areas, then I have this expression to this expression, and that is what it is. As far as restrictions that exist here, in a mathematical relationship, there really aren't any restrictions that can exist that are whole number values. However, if you do look back in practical situations, there are times when restrictions can exist. For example, here, x cannot equal negative 4. And in fact, not only could it not equal negative 4, it could not equal negative 3, it could not equal negative 1, and x could not equal negative 5. Now, assuming that x is some sort of arbitrary distance, that would be all fine and well. However, we don't have any parameters to suggest who is who and what is what, or solve for things. This may be something that we would do later on in our quadratics unit, is solve for particular values of x, given that we know what the area of the shaded region is or something like that. However, it does create the possibility that in the practical situation some restrictions can exist. Now, in our next unit, we're going to talk about something called a domain. And really what would be the scenario here is you really can't have a value for x that is, frankly, 5 or less. Because, less than 5. So x is really less than 5 rather than it can't equal 5. Less than negative 5 for this one here. And x can't be less than negative 1, and x can't be less than negative 3, and x can't be less than negative 4. So if you take this restriction here, it really means that x has to be less than or equal to negative 1. Now, because the negative 1 is not even possible, it's just a less than scenario there. Now, that is something that we call a domain if we're calling this a function. What it is a restriction that exists in the practical situation or in the mathematical situation. It either makes the function mathematically not possible, or it makes it practically impossible. In other words, here you couldn't have anything less than negative 1, because if you would, then some of your lengths would be negative. Okay, and unless you're dealing with physics where you have some vectors that have positive and negative quantities to them, it's not something that we normally would have or allow in the practical sense, even though the mathematics may allow it. Okay, so there's nothing technically that's not forbidden about it, but there is and are some parameters that will allow us to do so. Now, if you really wanted to find out what the restrictions are on this particular quadratic, you could use the quadratic formula to find out what the zeros are. And we would go ahead and figure out, using the quadratic formula, and it may give you nightmares, okay, but we are going to be doing this sort of stuff a little bit later on in our unit in quadratics. But if we were to figure this out, my restrictions would actually be, rather than x is equal to these, x is not equal to these. Okay, not equal to these. And we'll also talk a little bit later on about something called the discriminant, where we can actually take b squared minus 4ac and use that to determine how many zeros we have. Do we have 1, do we have 2, or do we have none? Okay, in other words, are there no possible values? In this case, b squared is 22 squared, which is, I think, 441. No, it's not. 484. And then 4 times 3 times 37. Okay, it's 444. So 484 minus 444 leaves me with a 40. Now, the root of 40 is not a whole number. Okay, but it is approximately 6.3 or something like that. So as a result, we could figure out that, negative 22 plus or minus the square root of 40 divided by 2 times my a value, which is 3, would actually tell me that there are what the particular values are that are the zeros for this situation. The zeros are mathematical zeros. They are not zeros for the practical sense. Okay, so when you're doing an application question, there's always going to be ones where situations in the practical sense that are going to be zeros, and there's going to be situations in the mathematical sense that will be zeros, and we have to consider both of those. Okay, so your homework, for those of you guys who are at home, okay, for today, my period 2A cohort students, the work I want you to work on are the difficult applications of section 2.6 and section 2.7. And some of these are pretty challenging. So have a look at those, do your best with those. It's a great opportunity for you to start reviewing for your test. In addition to that, please look at your Google Classroom, because it will mention to you, of course, what it is that you should be doing on top of this. Don't forget, we have our quiz, okay, on a lot of our Chapter 2 skills, Section 2.1 all the way through to 2.6, so omitting 2.5. We're going to be doing that at 9:55. That will be released to you guys, and you will have till 10:40, which is more than enough time for you to work on it. The intention is that you do not use your textbooks or any other notes, and I won't allow our classroom cohorts to do the same thing. Okay, and then we'll see what we're going to do from there. All right. So the other thing, of course, is we're also going to want to work on a review. And our review, I believe, is block 7. So this is block 6, and our review is block 7. So you're going to want to work on those two over the weekend. We'll take up the review on Monday, start some new concepts and new ideas on Monday, and then on Tuesday, on a Monday in our afternoon class, and then on Tuesday we will be writing our test. Okay? And the cohort A will be writing it in class, and the cohort B will be writing it at home. Okay? So have yourself a good night. Talk to you later.